Hello everyone, Dr. West here. So this is our final lecture of the class and of this particular section as well. So we're going to be talking through the last part of chapter 6, which is talking about drug use and drug misuse. And I am going to be tying it back in with what we were just talking about previously with biological rhythms and sleep, because we also had mentioned how sleeping was an altered state of consciousness and how it was a lower level of consciousness when you were asleep, that technically you weren't as low as some things like being in a coma, for example, but you weren't nearly as high level alertness as you would be, say, when you were stressed or taking an exam or something like that. So drug use can also alter your level of consciousness, and so that's what we're going to be talking about in this particular set of slides. Now, this is actually my favorite lecture of all of it. So when I was in graduate school, I actually studied drug and alcohol use. I gave alcohol to mice and I gave cocaine to rats and all kinds of stuff. So it was pretty interesting. But anyway, that was my journey into the field of neuroscience, and that's how I got to study and explore brains and things that I found interesting. So you'll hear a tiny bit about my research in here, but I'm going to try to mostly stay focused on some definitions and some things like that. If you want to know a little bit more about my stuff, hopefully you can come and take the next class with me, which is Psych 3113. So again, in this lecture, we're going to talk a little bit about what it means to be dependent on drugs. We'll give you a definition of addiction, and then we're just going to talk through some different psychoactive substances and what it means to call a drug a psychoactive substance. And then we'll talk about some influences of drug use on your actual body itself. Drugs themselves can affect your consciousness, and again, a drug can be any chemical compound that produces a desired change in the body. I'm jumping down here in definitions on the slide, but again, we think of drugs, and usually when you set up a lecture about drugs, people always think of just the illegal stuff. Drugs can be anything. Drugs can be legal things as well. So in a little while, you're going to hear me talk about stimulants, and I'm going to talk about some legal things like caffeine. Caffeine is a stimulant that is legal. You'll also hear, not necessarily in this lecture, but other kinds of drugs that are legal that absolutely can have an effect on the body would be things like Tylenol and ibuprofen and things like that you might take for a headache, for example. One that I talk about a lot because it has a major impact on me is Benadryl. So Benadryl is usually used when somebody is having some kind of like an allergic reaction or something like that. I'm allergic to, I'll just say trees because it's easier than trying to tell you all of the list of trees that I'm allergic to. I'm just allergic to trees. But again, once I sometimes have a flare-up of an allergic reaction, I'll sometimes have to take a Benadryl just to get it under control. But I try not to take Benadryl very often because when I do, yes, it is nice that it makes the mucus stop and it keeps me from feeling so congested and it keeps my throat from feeling so kind of clogged up. But it makes me very, 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 very sleepy. Because Benadryl is an antihistamine. Histamine makes you feel awake. So if you have an antihistamine, it's going to make you feel sleepy. That's one of the side effects of Benadryl. But it's not just like a little bit sleepy for a couple hours. It's like I will feel groggy for days. I call it the Benadryl hangover. I really will feel sleepy for like days. So again, even something like Benadryl can be considered a drug. It's going to produce a change in the body when you take it, right? But even Benadryl can be considered, this first definition here, a psychoactive drug. A psychoactive drug is also a chemical substance that you put in your body, but when you do, it changes your perception, behavior, and mood. In other words, it affects your consciousness, right? So some things that you take don't necessarily affect your consciousness. At least for me, when I take like Tylenol, it doesn't usually affect my consciousness. It might make me feel better, especially if I have a really bad headache, but it doesn't necessarily affect my consciousness. Benadryl absolutely affects my consciousness, right? I'm going to be, if not actively asleep, I'm going to be super groggy. I'm not going to be aware of things as well. I'm going to miss stuff. So again, psychoactive substances are any chemical substance that alters your perception, behavior, and mood. And again, these don't have to just be illegal substances. Caffeine does this for me in the morning. Yay, coffee. Benadryl can do this, but definitely illegal substances would fall into this category. If you think about the effects of cocaine or meth or something like that, those things would definitely also alter somebody's perception, behavior, and mood. Now, sometimes we actually even use psychoactive drugs to manage someone's neuropsychological illnesses. For example, things like antidepressant medications or something like that. We're purposefully taking advantage of the fact that a drug does alter perception, behavior, and mood. to bring somebody back to a place where they do want to be. So, for example, if you're taking an antidepressant, it will hopefully help you to stabilize your mood and bring it back to a more neutral territory versus having you start off in a very negative territory. So that's what a psychoactive drug is. So psychopharmacology is just the study of how drugs do that. How do the drugs actually interact with your nervous system and thus affect your behavior and ultimately affect your consciousness? And again, by altering things like your mood, your perception, things like that. We've discussed what drugs are. Addiction can result from some of these things. Addiction is just a craving for a chemical substance despite it having adverse consequences. And these can be physical cravings, psychological cravings, and the consequences can be anything. Can be a medical consequence, can be a social consequence. It can be, for example, like you lose relationships, you lose your job, you might lose money, whatever it might be. So addiction is just you still want that substance, right? You physically want it, like your body is feeling craving for it, or you psychologically know you want it, even though you're experiencing some kind of negative consequence or multiple negative consequences in your life. We would consider you to have an addiction to that substance. There are multiple ways that you can put drugs into your body. I'm going to talk to you about 4 of them. There's actually even more than this. So if drugs are going to actually affect you, they have to actually be able to get into your body. And more than that, they actually have to be able to get into the nervous system, specifically into the brain, so that they can start to have an effect. So they can actually go in there and produce a change to your consciousness level. The largest majority of legally used substances are going to be ingested in some way, which means they're going to be taken in the oral route. Most of these substances thus are relatively safe. They're the easiest usually to get somebody to take. So again, things like Tylenol and stuff like that are going to be taken in. You're just going to swallow the pill usually. Sometimes there are liquid forms that you can take, especially little kids. They have like liquid Tylenol, for example. The issue with these, though, is that they have to be absorbed via the digestive tract. So basically, you have to swallow them. It has to go down into your stomach. Basically, the stomach has to sort of dissolve it if it's in pill form. And it's either going to be dissolved in the stomach, or more likely than that, it's actually going to have to be dumped into the small intestine before it actually gets absorbed and dumped into the bloodstream. And then it's going to have to be sent from the bloodstream up into the brain. So it takes a while. It can actually take a while for the drug to start to take effect. That's another side effect or another issue that you would have to consider is how fast do you want the drug to work too. This is why sometimes there's like extended release medications where it's basically taking advantage of this process, right? Where it doesn't break it down immediately. And it makes it to where it doesn't dissolve as fast or whatever, so that you can ingest it slower and have it go into the bloodstream slower, which has to go to the brain slower, that sort of thing. But if you do want it to get there faster, ingestion is not going to be a good route. So if you want to get there a little bit faster, there are some other ways. Injection is going to help it get there a lot faster because it's going to bypass the digestive tract. Also, when you're giving it through ingestion, you probably have to give a lot more of the dose because not everything is actually going to get into the bloodstream. Some of it actually is just going to pass all the way through the digestive system, which means some of it is actually going to come out in the fecal matter. Or if it does get into the bloodstream, it's not even going to get to the brain. It's going to be filtered out by the kidneys and come out in the urine. So again, sometimes with medications, you're going to give way more than you would actually need should you give it in some other way, because it's going to be cleared out by the body before it has a chance to get to the brain and have an effect. Which is why when you give something via injection, you don't usually have to give as high of a dose. You can inject it into several different places. Again, straight into the vein would be called intravenous or IV delivery of the method. So again, this is where you stick it straight into the veins. You can actually deliver a drug straight into the brain. You can put it into one of the veins. It's in the brain, blood-brain barrier. Or you can actually put it straight into the ventricle of the brain. That's a lot more dangerous. That's not usually done unless there's an absolute emergency. Usually they pick a vein that's somewhere else in the body because that's still a really fast mechanism to get it to the brain. Sometimes drugs are injected into a muscle. Again, this is a little bit slower because, again, it has to be absorbed in by the muscle and all of the blood vessels into the muscle, so it's a little bit slower as well. That's usually where they're going to give you some sort of like vaccine, for example, right? Because they're going to let it go into the muscle so that the blood vessels that are in your muscle can deliver the immune system cells as well, so that it can sort of interact there. Or you can actually deliver it right under the skin. If you've ever had a TB test, they sort of slip right there under your skin. That's what they did there. It's called subcutaneous, or right underneath the skin. Depending on how close they get it and where they're putting it under your skin, it can be relatively fast, relatively slow. Again, it just kind of depends on the effect that they're going for. But definitely the fastest of all these routes would be an IV route. And that's probably what they would use in some sort of emergency situation. Definitely if you go into the hospital, they're usually going to insert an IV somewhere in you. That's definitely usually the fastest. But these are not even the only methods. You can actually inhale something as well. So think about some of the products that are typically smoked. So things like tobacco products, marijuana. What you're doing when you smoke it is you're actually bringing in the product into your lungs, and you're taking advantage of the fact that your lungs are covered with a bunch of little capillaries or blood vessels. And you're basically forcing, right, an exchange of drug within the blood vessels that are in your lungs. So actually inhalation is a pretty fast route as well. Some other drugs that are done this way that don't require actually smoke would be some of the allergy medications. So sometimes you'll see people using an inhaler, some kind of albuterol kind of inhaler for allergies. And you'll see them kind of breathing in this like mist-looking steam. That's what they're taking advantage of there as well. You can also absorb drugs through any kind of mucous membrane. So drugs can be taken up the nose. This is why, for example, some people might snort cocaine up the nose. You can have something dissolved in your mouth, either on the tongue or underneath the tongue. You could put drugs in your rectum, for example. You have a lot of mucous membranes in there. I'm not necessarily going to recommend that, but it can be done. This is done in an actual legitimate way if you would like. Sometimes when a person is constipated, they can give you medication that way to actually help to relieve the constipation and have you actually be able to have a bowel movement a lot easier. But you could use illegal substances that way as well. Again, I don't specifically suggest using illegal substances or administering them that way, but you could, for example. Again, there's even other ways that I didn't even mention here. You can put drugs in your eyes. There's just all kinds of ways you can get drugs into your body. The whole point is just get it in there so that it can get to the brain, is the whole point of drug administration. But again, if you're going to do so in a legal way, we want to make sure that we are getting it there as quickly as possible, but also as safely as possible. So when doctors are trying to decide if they're going to be giving you a substance, they're going to be looking at all of your medical history, and they're also going to be trying to decide what's the fastest way to get this medication to you, but also what's the safest way. So that's why typically the most common ways that people are going to be given medications are usually going to be, again, usually by ingestion, usually by an IV route, or usually by some sort of inhalation route. Again, you will see sometimes people will be given oxygen to inhale or something like that. All right, so once the drug has gotten to the nervous system, it's going to have its effect, but it's got to get there first. So we know that, again, if you take a drug orally, it is easy, it is really convenient, particularly for most adults, because they can just take it on their own, and doctors are usually pretty comfortable sending a patient home and trusting that they can take their own medication that way. But it does have the most barriers to get to the brain, right? Because it's got to go through the mouth, it's got to go through the stomach, usually also has to go through at least the small intestine, then it has to go into the bloodstream, and it has to hopefully not be filtered out by the kidneys before finally reaching the brain. So it's got a lot of barriers that it has to get through before it can actually have an effect. But there aren't quite as many barriers if the drug is injected directly into the bloodstream. That's why it's a lot faster. So the fewer the barriers encountered, all right, the better the psychoactive drug is, or the faster the psychoactive drug is going to actually have its effect. And it will have even fewer, obviously, if you inject it straight into the brain. But the other problem with that, and the reason why it's a little bit dangerous, is because you don't have some of those barriers. So it's also possible you could inject something else into the brain, for example, some kind of an infectious agent like a bacteria or something. So that's why that's not typically done very often. So with each barrier that you eliminate, you actually can reduce the amount of drug that you need to give by a factor of 10. This is what I mean by when you're giving something orally, you're going to be giving a much stronger dose than you would give if you actually gave something via IV, because a lot more of the drug is actually going to be able to make its way to the brain if you're giving it straight into the IV than if you're giving something by mouth and has to sort of go through all of those different barriers, and hopefully some of it makes it through. So again, what actually gets to the brain isn't even everything that got into the blood, and not just because it got filtered out by the kidneys. We've already talked in this class about the role of the blood-brain barrier. The blood-brain barrier doesn't just let everything across, right? Some stuff can go across. Oxygen, carbon dioxide, those can flow across very, very easily. They are fat soluble. They can just kind of float across. Other things are actively transported across. So glucose, that's the main fuel for the neurons, amino acids and things like that, they are actively transported across the blood-brain barrier. but a lot of other things don't. That's also why sometimes you can't just give a drug to somebody orally, or you can't necessarily even give a drug to somebody in an IV, because even if it's in their blood, it's not necessarily going to get into their brain, because the blood-brain barrier is not going to allow it to cross into the actual brain tissue. And this has been some of the difficulty in developing drugs that are specifically for the brain. That about 98% of all drugs that could affect brain function and actually have therapeutic use, our problem is that we can't get them into the brain itself, other than just literally squirting it into the brain, basically injecting it straight into the brain. And again, I just told you some of the effects of that. The problem with that, especially if you did it repeatedly, is you super increase the chances of also injecting some kind of infectious agent into the brain, and that's probably even more dangerous than whatever it is that you're trying to fix, because once you've introduced something infectious into the brain, your immune system is also not really active in the brain. Yes, you have a glial cell that sort of acts like an immune system, but it's not your true immune system, so it would leave your brain very, very vulnerable. An example of this is actually dopamine for people that have Parkinson's disease, which we've talked about in a previous lecture. We talked about deep brain stimulation. You saw the video, or hopefully you watched the video of the man that had deep brain stimulation. But one of the other alternatives to deep brain stimulation is giving patients artificial dopamine. That was one of the earliest proposed things. Well, if these people are having trouble making dopamine, why don't we just give them some dopamine and see if that helps? And what we quickly found is, because we knew how to make artificial dopamine, we quickly found, well, that doesn't work at all. And the biggest problem is because the brain, the blood-brain barrier, wouldn't let the artificial dopamine pass through. Even though there's dopamine in your brain, it just was not one of the things that it would let pass through. Now, interestingly, we found that if you chemically altered the dopamine just a little bit into something called L-DOPA, which is, again, just some slight chemical changes, it will cross the blood-brain barrier. So this is a medication that is sometimes given to early-stage Parkinson's patients. And what happens is that the L-DOPA will cross the blood-brain barrier. And then once it gets into the brain will convert it back into dopamine. So the brain will take that L-DOPA and convert it back into dopamine. And that does provide some relief for early-stage Parkinson's patients. But again, this is a big problem. Is, again, not just getting it into the body, and not even just getting it into the bloodstream, but getting it past the blood-brain barrier. All right, let's pretend it did get into the body. Let's pretend it did have an effect. Now we need to get it back out, right? Because you don't want drugs to stay in your body forever. So drugs are mainly broken down in three major places: the kidneys, the liver, and the intestines. The liver probably does the biggest chunk of the actual breaking down work. We call that catabolizing or metabolizing the drugs. Typically what the liver will do is it has a whole bunch of what we call enzymes that actually break the drug down into smaller pieces. And then the liver will dump all those pieces back into the blood. And then the blood will get filtered out by the kidneys. So it's kind of like a 1-2 punch. The liver and kidneys kind of work together to filter out your body. So the liver takes the drugs, breaks them down into a bunch of little pieces, and then the kidneys filter all those little pieces out of the blood. And the liver is capable of basically breaking down drugs into a lot of different things that can be excreted from the body. But again, the liver doesn't do everything. The intestines do some. But we also know that drugs can be excreted more than just in your urine, which would come from the kidneys. You can have some drugs that come out in the feces because they never left the digestive system. You can have drugs that come out in your sweat. Drugs can come out in breast milk, which is why some things should or should not be taken when you are breastfeeding. If you're a mother that's breastfeeding a child, there'll be some medications that your doctor or pharmacist will warn you about. There are some drugs that can come out actually in your exhaled air. So again, it's not only this one route, it's just that the liver and kidneys are probably the main route for most substances. And then there are some substances that don't really get removed very well, or at least very fast at all. THC is one that we're going to talk about. That's the main active substance in marijuana. It does get removed by the body, it just doesn't get removed very quickly, and so it builds up in the body. Now, THC is not one of the ones that typically builds up and becomes toxic, but it does take a while for it to actually get removed. So again, it will actually show up quite a while later after you've used that substance. But there are some that just don't get removed over time and can become toxic. Lead is one of those that doesn't get removed very well. And if you have too much lead that builds up in your body, it can become toxic. Most psychoactive drugs are going to exert their effects by messing up a synapse. All right, so if you think about a synapse, this is why I said everything's going to sort of build on itself. All right, you have the side that is the sending side, so it's the end of the axon that's going to send out the neurotransmitter, and then you have the receiving side that's usually a dendrite. It's going to have receptors to catch something. All right, drugs are going to have an effect, all right, at somewhere in that range, somewhere at that synapse. So they can either act in one of two ways. Drugs can act as an agonist, and what agonists do is basically enhance or mimic, right, a neurotransmitter. So they will enhance the function of a synapse. Usually what they'll do is they themselves will bind to a receptor, just like a neurotransmitter would do, and either help the neurotransmitter bind or trick the receptor into thinking it is a neurotransmitter, and so it can stimulate the cell. Or it can act as an antagonist. And what an antagonist will do, again, is still go and bind to a receptor, but then block that receptor so that the neurotransmitter can't bind and can't do what it's going to do. And I'll show you an example, and I'll talk you through some of these as we move into some of the different kinds of substances. But basically, agonists enhance and make the synapse work better or more effectively, right? So it's going to feel like you're probably sped up. Antagonists block or decrease the function of a synapse, so it doesn't work as well. And I'm going to show you an example of this in just a minute as well. Some characteristics of abused substances. So pretty much all substances that are going to be abused and that could potentially become addictive stimulate a very specific pathway in the brain. Now, this does not mean it's the only part of the brain that's stimulated. It's just this pathway is very, very, very important for addictive substances, and we call it the dopamine reward pathway. So in your brain, you have two dopamine pathways. They both start sort of back here. You have one of them that sort of goes up into the middle. That's the one that gets messed up by Parkinson's disease. But then you have this other one that starts in a place called the ventral tegmental area, or the VTA, and it goes to a spot called the nucleus accumbens, all right? And then it goes up into the frontal lobe, specifically part of the prefrontal cortex, as well as the rest of the frontal lobe. And it's releasing dopamine the whole time. And this is a series of brain regions. This is a whole pathway that spills out a whole bunch of dopamine. And when this pathway spills out a whole bunch of dopamine, what you experience, because you have no idea it's actually happening as far as dopamine being released, but what you're consciously experiencing is a pleasurable, rewarding sensation. You feel good when this pathway gets activated. And it's not just drugs that can make it happen. There's lots of things that can activate this reward pathway. Right? So think of things that you enjoy in life. Your favorite food, and when you get a chance to eat your favorite food, probably activates this pathway. When you do your favorite activity, whatever that might be, if you love singing karaoke, for you, karaoke probably activates it. If you love watching movies probably activates this. If you like driving race cars probably activates this pathway, right? Whatever it might be for you, activates this dopamine reward pathway. Whatever you find rewarding, whatever you find pleasurable, whatever you find good. Humans are programmed to have certain things automatically activate this reward pathway. Food, especially our favorites, usually do, right? If you're really thirsty, liquids do, right? And then to keep our species alive in general, things like sex and sexual reproduction usually do, right? But what happens with drugs of abuse is that they take over this pathway and they sort of hijack it to the point where none of the things that usually make us feel good anymore. And all we can focus on and concentrate on, and if you remember what the front part of your brain did, which was make decisions and help you plan, all of that front part of our brain, all it can seem to think about and plan and decide to do is to look for more drug to re-stimulate this pathway again. So that's the problem with drugs of abuse, is they sort of take over this naturally rewarding pathway that should reward you for things that keep you alive and keep our species alive, and it focuses you on getting more of the drug. What we also know about abused substances is that most rodents will self-administer them. This is why I was working with mice and giving them alcohol, and rats and giving them cocaine. Man, rats love cocaine. We also know that most drugs of abuse will be absorbed and distributed throughout the body, but particularly into the nervous system pretty quickly, and that most of them will pass across the blood-brain barrier fairly quickly. That's actually why they're able to be drugs of abuse. We also know that you can become dependent on these drugs and produce something called tolerance, which basically just means after you've used the drug for a while, you stop kind of feeling the effect and you need a little bit more to get that effect. So if you think about it in terms of using like alcohol, for example, right? You used to be able to drink 1 or 2 drinks of alcohol to get a good buzz, but now you drink 1 or 2 and you don't feel that buzz anymore. So now you have to drink 3 or 4 to get that buzz. And then after a while, even 3 or 4 doesn't give you a buzz, and you have to drink 5, and you have to drink 6, right? This is what tolerance means, right? Is that after you've used psychoactive substances for a while, your body has gotten repeated exposure to it, the drug stops having as much of an effect, basically because your body kind of compensates for it. So that's what this graph is basically showing you. How much of a drug effect, how much of the drug did you use? Well, again, at first, if you use a little bit of the drug, you have a little bit of effect. If you use a little bit more of the drug, you're going to have a much more of an effect. But after a while, you're going to have to use more drug just to have a little bit of effect. So you're going to have to use a ton of drug just to have that same effect that you had before. This is tolerance. And this is what can be so dangerous and can lead to overdose. People don't know exactly how much they need to get the buzz that they want, or to get the high that they want, or to get the sensation that they want, particularly when it's not something like alcohol where you can sort of start and stop, and it's something like cocaine where you have to just snort some and hope for the right effect, and it may or may not even be pure. You might also feel bad if you stop using the drug, and that can even make you want to keep using the drug, because if you're going to feel bad if you stop using it, you probably don't want to stop using it. And we call that specifically withdrawal. So upon stopping using the drug, or especially after you've been addicted to it, you might experience some undesirable effects, and we call that withdrawal. Now, usually the particular withdrawal symptoms that you're going to have are going to sort of be opposite of whatever the actual effect of the drug was. So if you're taking a depressant, the withdrawal effects are going to be feeling more like stimulants. You're going to feel irritable and kind of awake and just itchy and irritable, right? If you're taking a stimulant, you're going to feel sort of depressed and down, right? So the withdrawal effects, none of them are pleasant. Right? Nobody usually says they feel good after withdrawing from a substance, right? But withdrawal can also prompt someone to want to continue using a drug. So it's kind of like this double hit when you're addicted to the substance. So not only is it activating this reward pathway so that taking the drug feels good, but stopping taking the drug feels bad. So it's like a 1-2 punch there as well. And the other reason why it feels so good and feels so bad all at the same time is because your body has become dependent on the drug. And this is part of what leads to the tolerance as well. Your body actually physically can become dependent on the drug, which means you will have physical symptoms if you don't have that drug in your body. You might even feel physical pain wanting that drug. I've had a lot of people that say, especially if they're addicted to tobacco and they don't have their tobacco when they want it, they can't have their smoke or their dip or whatever it is, they really just feel physical, like it physically hurts, and they're so super irritable, which leads to the next part, which is psychological dependence. I actually have felt this actually with a legal substance, in this case of caffeine. I joke about it a lot that my blood type is coffee, but I really do love to drink caffeine, specifically coffee. Coffee is my absolute favorite. And I've done a really good job in the last several years of cutting back on the amount of caffeine that I drink. I pretty much only drink coffee now. I've cut out all other kinds of things. Like I don't drink soda anymore. I definitely don't drink energy drinks anymore, although I used to. But I can definitely tell you at one point a while back, I was definitely dependent on the caffeine. And if I didn't have a certain amount by a certain point, about mid-morning, I would have this just horrific headache. That's the physical dependence, right? It's like my body was screaming, give me the caffeine, right? And I was just grumpy and irritable and just not fun to be around. And that's the psychological dependent part. It's like I knew I didn't have enough, right? I knew I didn't have enough coffee, or I knew I didn't have an energy drink when I wanted it. Right? So dependence is also a big problem as well. All right, the last part of this lecture is going to be about the psychoactive substances, but I think I'm actually going to break it up so that it's not quite as long, and I'm going to make one final video after this. So I'm going to make one final video where I talk about the different substances. So I will be back for part 2 in just a minute.